We're talking about something called the mean value theorem. Mean value theorem. We've talked about the intermediate value theorem, the extreme value theorem. Now the mean value theorem. Mean is an average, right? Average. You see on the board here, I have average rate of change. Average rate of change is over the course of an hour, how fast was I going in my car, right? Instantaneous rate of change is the derivative at that time, right? So if I'm driving in my car and I look down and it says 35 miles an hour, that's your instantaneous rate of change. At that moment, you're going, your rate is changing 35 miles per hour, right? Average rate of change is over the course of a trip to San Francisco, over 3 hours, right? How fast was I going? That's the difference between them. Okay, that's the difference between them. One is the derivative at one moment. One is the derivative over a course. So this guy here, the green one I have in front, it's not green on your paper, but it's green up here. This is an example of average rate of change. It's a secant line. It's not a tangent line, right? Instantaneous rate of changes are tangent lines. Average rate of changes are secant lines. Secant lines means it cuts through. It cuts through. You can see where the green cuts through the red. Okay. So today what we're going to talk about is a combination of both. Combination of average rate of change, instantaneous rate of change. So sometimes they'll say that. So I'll say, what's the instantaneous rate of change at this? We'll just find the derivative and plug it in. We've done that before. Average rate of change is over the course of however long. Okay. So this green line represents the the average rate of change from 0 to about like 4.4, 4.3. Okay. So the average rate of change would be down a unit over 1, 2, 3, 4, about 4.3, 4.4. So -1 over about 4.4 maybe-ish. Okay. That's over the course of something. So this is what the mean value theorem. One of the things in a lot of this can be applied in real life. That's why a lot of people who take science, if you want science to be your major, you have to take calculus class. Like, what does science have to do with math? Because this is applicable. It's applicable. Okay. Obviously, if you want to do something in math, anything in STEM, you have to take a calculus class. Engineering, science, technology, mathematics, because of things like the mean value theorem. Okay, so where is the mean value theorem? Mean value theorem, anyone who drives, anyone who's got a license drives a car. The mean value theorem applies in your life. I'll tell you how. So let's say I'm going on a trip. Let's say I'm going on a trip to San Francisco. It takes me about 3 hours to go, right? So let's say I go from, so let's say San Francisco, let's say San Francisco is 180 miles away. Took me 3 hours. So that means I averaged 60 miles per hour, right? That means I averaged 60 miles per hour, right? What the mean value theorem says is, since you average 60 miles an hour, that means at least one time in your trip, at least in one instance in your trip, you were going 60 miles an hour. Makes sense, right? Makes sense. At least one. Could I have gone faster? Could I have gone slower? Yeah, of course, right? Of course, I could have gone faster. I could have gone slower. Okay. Problem is, let's say this. Let's say my friend did the same trip, except he took 2 hours. His only took 2 hours. So what was his average rate of change? 90. Well, as we know, 90 miles an hour is way over the speed limit, right? And I'm like, you must have been speeding. He's like, no, I wasn't. You had to have been speeding, right? You had to have been speeding because the mean value theorem says if your average rate of change was 90 miles an hour, you had to have been going 90 miles an hour at least one time. At least you had to have, right? That's what the mean value theorem says. Okay, so it compares the average rate of change with the instantaneous rate of change. Okay, so once we used to have speed traps in California. There's a couple different speed traps, but the speed trap we used to have in California was there. You'd be driving down the highway, and there'd be a police officer there. Doesn't pull anybody over, just as people are going by. And then about a couple miles down the road, there'd be another officer pulling people over. But they weren't taking anyone's speed. They weren't registering people's speed. They didn't have the gun on them, the radar gun, right? They kept the guns away because they know people have radar detectors. So they're like, we'll put the guns away. We're not going to be checking speed. We're checking my clock, right? So if you got from point A to point B in a certain amount of time, they know somewhere along the line you had to have been speeding, whatever the 70 miles an hour, whatever it is, right? So what they figured out was, so if I'm 2 miles down the road, right? If I'm 2 miles down the road, you can only go on this road 70 miles an hour is the top speed. Anything over that is considered illegal. I can give you a ticket, right? If it's a highway. Most highways, 70 miles an hour. In the city is probably 65, but if you're going somewhere and it's not in the city, it's usually around 70. So they're like, what time would you get to me? Well, if I went, so if it took me 1 minute, right? If it took me 1 minute to get to you, how fast were they going? Well, how fast? How fast were they going? If it took me 1 minute to get from one cop to the other, how fast were you go? No, miles an hour. How fast were you going? In a car, how fast were you going? 2 miles an hour. Or how many miles an hour were you going? How do we figure that out? I know you're going 2 miles in a minute, but how many miles per hour? So you're going 120, right? 120 miles an hour. Even though I didn't actually clock you as 120, I know for a fact you were going 120 somewhere along the line, right? So they figure out what's the number. What about 1.5? What about 1.5? If it took you a minute and a half to get to me, how fast were you going? I'm here. My buddy is 2 miles down the road. It took you a minute and a half to get from here to here. How fast were you going? Close. 90 miles an hour. 90 miles an hour. Over the speed limit, even though I didn't clock you. I don't have a radar gun on you. I can still give you a ticket because I know by the mean value theorem that you were speeding. You had to have been. There's no way you could have gotten to me from me to them in a minute and a half. So they figure that out. It's like 1.3, 1.2, something like that. Oops, no. It's about 1.6, 1.7, something like that. They figure out the math. They figure out the math so that they can say, if that car crosses me in less than that time there, I know they were speeding somewhere. Because their average rate of change was too fast. So somewhere along the line, they were going past 70. I can give them a ticket. I don't even need to know what speed they were going, right? They give them a ticket based on their average rate of change, right? It's called the speed trap. Okay. You don't really see it a lot, but sometimes you do. Sometimes you do. So you just got to be careful with how you're driving. Because, like I said, cops are very smart. They know people have radar detectors. So people have radar guns and so they put those away. We're not going to use them. Turn them off. But they use the tricks like this, right? It's not really a trick because they're using calculus, right? You can't, it's proof. This is proof, right? That you were going, I don't know where, I don't know what time, but sometime between me and him, you were going over the speed limit based on mean value theorem. That's what the mean value theorem says. Okay? That's what the mean value theorem says. So if you hear about a speed trap, that's what they're talking about. That's what they're talking about. Okay? So when can we use the mean value theorem? Well, there has to be two things that be true. Has to be continuous. So in the interval, it has to be continuous. If it's not continuous, you can't use mean value theorem. Has to be differentiable. Has to also have a derivative from A to B. Okay, has to be continuous and has to have a derivative. Okay, if both of those are true, then there exists at least one point where C equals this guy right here. Okay, so what does this guy refer to? Right, the derivative at C starts with an I. It's on the board. Instantaneous, right? This guy refers to instantaneous rate of change. Derivative, plug in my number. This guy refers to the average rate of change, right? I'm going to set them equal to each other and solve. That's what you're doing today. You're finding the derivative and plugging it in. You've done that before. And then you're finding the average rate of change. That's just slope. You're finding slope. You've been doing slope since probably 7th grade. Okay? Slope, I put it on the board as the version you probably y2 minus y1 over x2 minus x1. Instead of, they didn't use 1s and 2s, they use a's and b's, so I put b's and a's. That's the only difference. Okay? So what you're doing is this. Math, or visually, I'll show you. First thing you have to do is find the slope of this guy. That's the first thing you have to do. Okay? Then the second thing you have to do is they'll give you a point. They'll say right here. Well, let's make it a whole number right here. Find the derivative at that point there, because that's where they're going to match. Okay? That's what we have to do. That's right here in a nutshell, our steps right here, that yellow part. Okay? So let's look at example number 1. Apply the mean value theorem to the function in the indicated interval. Each case, make sure the hypothesis is true. Then find all values of C inside the interval guaranteed by the mean value theorem. So anytime you see MVT, mean value theorem, this is what you're going to do. That's what you're going to do. Okay? So the first thing we have to do is make sure the hypothesis is true. Make sure both of these guys are true. That's the first thing we have to do. Okay, so from -1 to +1, is this guy going to always be continuous? In other words, is there any number from -1 to 1 where I plug it in here, it would give me undefined? No. Always will give me an answer. Maybe a decimal, maybe a fraction, maybe a negative, maybe a positive, but it'll always give me an answer. If I plug in any number here, it'll always chug out some number, right? It's a function. If I were to find the derivative of this guy, would I still be able to plug in any number here and get an answer out? Yeah, right? I wouldn't have. The only issue with derivatives is what's the only issue with derivatives? That would fail this guy here. When would we fail this guy here? What's true about the derivatives? So if f of x is not continuous, definitely not differentiable. Okay? But with only the derivative, when is a derivative not differentiable? When is something not differentiable, in other words? When it's not continuous, that's the first thing. So if I'm looking at something, how do I know if it's differentiable or not? We did that. That was the last thing we talked about last chapter. You had a question on your test about it. How do we know something is not differentiable? When what? When do I know something is not differentiable or is differentiable?
when we put all the values equal to each other, like for the derivative of a point, then if they're not equal, they're not differentiable.
Exactly, right? These two guys here, corners, right? Corners, not differentiable, right? Um, Points like that, cusp points like that, not differentiable, right? And also, if it's not continuous, right? Well, this guy's not going to do any of those. That guy's not going to do any of those. So we don't have to worry about that. If I were to distribute, I get x cubed. I get x cubed minus x squared minus 2x. That's going to look like that. It's going to look like a regular cubic. Okay? Okay, so we know the hypothesis is true. We know these two guys are true because we did that. We know how to check those. We did that last chapter. Okay? Okay. Find all of the values of C inside the interval guaranteed by the mean value theorem. So it's guaranteed now. Since these guys are true, has to be guaranteed that there is a C where the instantaneous equals the average. Okay. Which one is probably easier to find? This is a subjective question. It's not objective. It's a subjective question. Which one would be easier to find? There's not one answer. There's multiple answers. But for you guys, which one would be easier to find? Instantaneous or average rate of change? Which one looks more like something we've seen before many, 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 many times? So yeah, you could say either. You've seen this probably since 7th grade. So you're probably familiar with that. Probably didn't see it in math 2 a lot, math 3 a lot, but math 1 you saw it, and in middle school you saw it. This you guys have seen a lot this semester already, right? Find the derivative, plug in a number. So it's either whichever one kind of you're more familiar with, start with. Okay? So let's start with this guy here. Let's start with this guy here. It says find the derivative, plug C in. Okay? So before I find the derivative though, I'm going to do what I talked about earlier. I don't want to have to do product rule. So I'm just going to do distributive property so I don't have to deal with product rule. Otherwise I would have to, oops, not 1x, 2x squared, just x squared. Otherwise I would have had to have done product rule. Okay. F prime 3x squared minus 2x minus 2. Plug in C. What number do I plug in? Yeah, because that's what it says, right? F prime of C. I'm going to plug in C to X. So which number am I going to plug in? Kind of a trick question.
Any number between the interval?
No. It's kind of a trick question. If I knew what number to plug in here, what is the question asking me? Sorry, we'll start with that. What is the question asking me? What do I need to find? C. I need to find C, right? So that's why I said it's a trick question. If I knew what to plug in, I'd be done with the problem, right? I don't know what to plug in yet, so I'm just going to leave that alone, right? So I'm going to leave it alone for right now. This is what I'm going to, that's the derivative. So when I get C, I know where to plug it in. Okay? Okay. So done with that. Now let's do the slope part. Let's do the slope part. Okay? So in order to do slope, I need 2 points. Do I have 2 points? In order to do slope, right? Y2 minus y1 over x2 minus x1. I need 2 points. That's how I need, right? Do I have 2 points? So is that a point? So do I have, so yeah, it's not a point, it's an interval, right? So what does that mean? If I have an interval, what does that mean? So they're two x values. So I have half of 2 points. I have half of 2 points, right? I have half of the first and half of the second. How do I get the second part of it? Plug it in. Do it right now. Fill it in. What's going to be here and here? Where do I plug it into? F of x. The original, not the derivative. The only time we plug things into the derivative is where we're doing the first derivative test. I am not doing the first derivative test. I am trying to find out points on the original graph. So you're going to plug it into the original graph. So don't look up here. Look at your paper. You guys know how to do this part. So I get negative 1, 0. And then I get negative 2. 1, negative 2. Those are my 2 points, right? So what I just found was this guy right here. Here to here. I just found where is the first point, where is the second point. That's what I found. Now I'm going to find the slope. That's where y2 minus y1 over x2 minus x1 comes in. So y2 minus y1 over x2 minus x1. So we have negative 2 minus 0 over 1 minus a negative 1. You get negative 2 over positive 2, which is the same as negative 1. So the average rate of change from negative 1 to positive 1 is negative 1. Down 1 over 1, down 1 over 1. Okay? Okay, so now I have the derivative. I have the average rate of change. What do I do now? Set them equal to each other. Set them equal to each other. That's what it says. Set them equal to each other. Once you found both, set them equal to each other. Okay? 3x squared minus 2x minus 2. I need to know when that equals negative 1. When that equals negative 1, that'll be my C value. Okay? So I'm going to add 1 to both sides. It's a quadratic function. 3x squared minus 2x minus 1 equals 0. Let's see. So it's going to be negative 3 add up to be negative 2. So that's negative 3 and 1. So I get 3x, x plus 1, x minus 1. So I get 3x plus 1 and x minus 1. Just factored those guys. Just factored like you did in Math 2 and Math 3. I know you guys did it there because I teach Math 2, or I taught Math 2 and I teach Math 3, and that's what we do. So I know you guys have done it there. You might not forget, might not remember, but it's one of those skills. Factoring is one of those skills that we use in all levels of math. So I need to set it equal to 0 now. So we add 1. Subtract 1, divide by 3. Okay, this part right here. This is one of those skills that's hugely important. This is a Math 2. This actually is a Math 2 standard. Here, have to be able to do this. Like when you see something like this, you got to be able to solve it quick. Okay, otherwise the calculus is just going to get harder, because to be good and to do well in calculus, you have to have strong skills from Math 2, Math 3 especially. Okay, so I have two answers. I get x equals 1 and x equals negative 1/3. What are the answers though? Hmm? No. What are those numbers? So how did we get those numbers? We set this guy equal to this guy, right? What was the first guy? What did the first guy represent? Derivative of the original, right? What did negative 1 represent? The average rate of change. When they're equal, that's where C exists. So these guys are C. Those guys are C. Okay? So in other words, C equals negative 1/3, comma, 1. There's 2 points where you would have the same slope, instantaneous rate of change as average rate of change. If you don't believe me, look at the back of your paper. Look at the back. I have the actual graph on here, and I'm going to show you what this actually means visually. Okay? So this is the graph of the one we just found. So we went from negative 1 to positive 1. That was our interval, negative 1 to positive 1. So the blue dot to blue dot. What is the slope of the line made by connecting those two? So if I were to connect these two, what do you think the slope was? Negative 1. Good, right? Negative 1. That's what we found. You can look at it. I go down 2 over 2. That's negative 1. So what our graph, or so what the mean value theorem told us was at 1, when x equals 1. So let's go find where x equals 1. It's the same as the blue, right? If I were to find the slope of the tangent line here, the slope of the tangent line, if I were to find the slope of the tangent line here, it would be the same slope as the blue line. That's true. And at negative 1/3. Negative 1/3 is like right about here. If I were to find the slope of that tangent line, it would be parallel to the blue line. That's true. That's what it tells us. Where in between the 2 points is, are you actually going to have the same slope as the average rate of change? That's what the mean value theorem says. Where along the road were you going the same speed that I clocked you, that you were going, right? So if you got from 1.5 minutes from here to here, where along the road were you going 90 miles an hour? Where exactly along the road? Where along the interval were you going? Okay, that's what the question is asking. Okay, all right. So now I want you to do the second one. Be careful with the second one. That's all I'm going to say. I'm going to let you guys work. So why should this question take you about 30 seconds? The last one took us, 10 minutes. We were working on it for a while, right? This one should take you 30 seconds. And I see some of you guys, your pencils are already down because you're like, wait a second. What's the wait a second moment? What's about this guy? Yeah, sure, Steve.
It doesn't fulfill the conditions of the hypothesis.
First thing we have to do is say, make sure the hypothesis is true. Make sure these guys are true, right? That's the first thing we did. Is it continuous over the interval? So from -3 to 5, is there any number, is there any x value I could plug in to this guy here between from -3 to 5 that would cause an undefined? Which number? 1, right? 1, it has an asymptote. It's got an asymptote at 1. That's within the interval, right? So because of that, we would say mean value theorem, MVT, does not apply. Because f of x is not continuous at x equals 1. We can't do it. And this is the thing. If I would have let you guys work, you would have gotten an answer. You would have gotten an answer. And you're like, oh, I got an answer 5 minutes later. But it would have been all wrong because we can't even use the rule, right? We can't even use the rule because it didn't apply. So sometimes they'll slip one in there like that. So you got to be able to check to see continuity. If it's not continuous, you're done, right? If you're not continuous, you're done. If I would have found the derivative of this guy, it would have had the same issue because of that asymptote, okay? Because x minus 1 would have still been an asymptote. Because if you find the derivative of this guy, some of you forgot this on the test. If you find the derivative of this guy, what should go on the bottom? This squared. A couple of you missed that. You did everything right, but you forgot about the bottom of the quotient rule. So I couldn't give you full credit. So I gave you like half credit. Okay? So if I were to find the derivative of this guy, I would still have x minus 1 on the bottom. It would just be squared, right? And that's an asymptote. Okay? Okay, so let's go to this one. Let's go to the next one. Here, cross out this part here. This part here, plot a line segment connecting the points. You don't have to do that. Determine all the values of C which satisfies the conclusion of the mean value theorem. This is the one I want you to do. Okay? Number 3. Make sure my points match up to your points. I got, for the 2 points, I got -6, -5, and then the second one I got -343. Did I say I'm wrong? It feels like the bottom one's wrong.
It's -3 cubed.
Oh, yeah. That's why. Thank you. Felt wrong when I did it. So that guy is going to be 36. And then 36. See, 36 minus 17 is 24, minus 17 is 7. -37. Okay. Okay. So now I have the derivative. It's in yellow. I have to set that equal to the average rate of change. I have my 2 points. Plug them in. Which is y1, which is y2, which is x1, which is x2? Yes and no. The answer is doesn't matter. Just be consistent. This could be your first point, x1 and x2, x1 and y1, or this could be your first one, x1, y1. It doesn't matter. Order doesn't matter. You'll get the same answer. Okay, so average rate of change is going to be y's. As long as you get the y's on top, x's on bottom, you're good. Minus 7 and negative 6 minus a negative 3. Average rate of change is positive 4. It's my other green guy, or yellow guy. Found the average rate of change from negative 6 to negative 3. Found the derivative of f. Set them equal to each other. Subtract 4 from both sides. So I get 3x squared plus 14x equals 0. This one's a binomial, so I can just factor out a GCF. GCF is x. So I get 3x plus 14. X equals 0. That was an easy one. And then 3x plus 14 equals 0. X equals negative 14 thirds, which is around negative 4, between negative 4 and negative 5. Don't change it to a decimal. Don't change it to a mixed number. Leave it like that. But here's a good question here. On a test, I could ask the same question. And I would say A, B, C, and D. Multiple choice. Multiple choice. C equals 0 and negative 14 thirds. C equals 0. C equals negative 14 thirds. There is no C. Empty set means there is no C. What answer is it? A, B, C, or D? Both of them? That would actually be wrong. Why would that be wrong? A is not correct. Why is A not correct? 0 isn't in the interval. Yeah, look at the interval. I don't care about any number outside the interval. I don't care about any C's outside the interval. 0 is outside the interval. Negative 14 thirds is inside the interval. That one is okay. So my answer would be C. Okay? Make sure you check the interval. Check the interval. Because if you get an answer that's outside the interval, I don't care about it. I only care about from negative 6 to negative 3. Any x values, any c values outside of that, I could care less about. Okay? So you might get some because those are zeros, because these are zeros of the function here, but we just don't care about that. Because if I had an interval from negative 6 to 0, then both of my answers are there, right? They could have opened up the interval, but they didn't. They closed it. Okay, so just be careful there. Okay, Let's see. Last two we'll do tomorrow, and then I'll give you tomorrow. What we'll do is we'll finish the last two, and then I'll give you the rest of the time to start on your assignment and work on your assignment from yesterday. Okay, either